Hi friends, my name is Amita and in this video I am going to discuss about a very important technique of a network analysis, that is nodal analysis. Dear friends, before going into detail of a nodal analysis, I just want to make it clear to you the meaning of a network analysis. Dear friends, any network is having three basic things. One is input, another is system parameters, and third one is the output. When we know the input and we know the system parameters, then to determine the value of the output is called as a network analysis. Opposite to that, if I know the input, if I know the output, and to determine the value of the system parameters is called as a network synthesis. As in this video, I am going to discuss about one of a technique of a network analysis, that is nodal analysis. Means by applying this method, I can determine the current or the voltage drop or the power loss in any element of the circuit. So now, my dear friends, without wasting time, I am directly sharing my board where I will explain you the nodal analysis method with the help of some example. So let us start with the method, that is nodal analysis. The very first point about it is the method of network analysis. It means with the help of this method, we can determine the value of output, that is current or voltage drop or power loss across any element of the circuit. The third thing is, it is the frequently used method. And the very important thing is, it is the application of KCL, that is Kirchhoff's current law. Okay, so that's the some facts about network analysis, some facts about nodal analysis. Now, before understanding the nodal analysis, let me clear what is node. You should be aware about few terminologies, node and branch. So, node is nothing but it is the interconnecting point of a network where two or more than two electrical elements are connected. As I am saying, electrical elements are connected means these electrical elements can be an active element and it can be a passive element. Active elements are those elements which give some energy to the circuit. Passive elements are those elements which only consume the energy. They are not the source of the energy. So this is the node. Now the next thing is branch. Branch, it is the interconnecting link between the nodes. Okay, so I will clear this with one circuit. Like suppose this is the circuit which consists of resistance, inductance and so many elements, capacitance also. Suppose this is a DC source of 10 volt, this is 10 ohm, this is 5 ohms, this is 1 Henry, this is 1 microfarad and this is 20 angle 0. It's a AC source. So if I identify first I will identify the nodes. So what is the definition of node? Node is nothing but it is the interconnecting point between the two or more than two branches. So one node can be this, as here one active element and one passive element is connected. Another node is this, as three passive elements are connected at this point. So this is node number 1, this is node number 2. This is also a node as the capacitor and one active source is connected. So this is node number 3. This is node number 4. Here voltage source and resistance is connected. This is node number 5. This cannot be a node because here the short circuit is there. So whatever the potential will be at 5, that will be the potential at this point. So this particular circuit is having how many nodes? It is having 5 nodes. Total number of nodes are 5. And how many branches are there? Like this 10 ohm resistance is connecting between node 1 and 2. So it will be a branch. So this is branch number 1. This inductance is the connection between node number 2 and 5. So it is branch number 2. This is branch number 3. This is branch number 4. This is branch number 5. This is branch number 6. So total number of branches are, so I think now it is clear how to identify the nodes in a given circuit and how to identify the branches. As the given circuit is having 5 number of nodes and the number of branches available in this circuit are 6. Now let us try to understand the steps of nodal analysis. So now I am directly switching to the method nodal analysis. The very important thing is it is the application of KCL. Second, here we write Kirchhoff current law equations for the nodes where voltages are unknown, then are unknown. Now it is the application of KCL. Now as it is the application of KCL, so first we should be aware what is KCL. KCL is nothing but it is a Kirchhoff's current law. Now what is the statement of Kirchhoff current law? Let me write this statement. As per this law, the algebraic sum of current at any node is equal to 0. Or I can write the incoming current at any node is equal to outgoing current from that node. So this is the statement of an Kirchhoff current law. Now if I want to represent this statement mathematically, I can write sigma in is equal to 0, where n is equal to 1 to m. Similarly, if I want to write here, so I can write sigma is equal to 1 to m, in is equal to sigma x is equal to 1 to y I x, where n are the number of incoming branches and m are the number of incoming branches and y are the outgoing branches. So this is something about the Kirchhoff current law, and Kirchhoff current law is nothing but it is the first law given by the Kirchhoff, and it is based on the energy, it is based on the conservation of charge. As the algebraic sum of current is equal to 0 and current is nothing but it is the rate of change of charge, so it is based on the principle of conservation of charge. Now let me brief about the steps of nodal analysis. What are the steps of solving the numerical for the nodal analysis? Number 1, identify the nodes in a given circuit where voltages are unknown. Then second, consider one node at a time and assume the direction of current in each branch connected to that node away from node except the branch which is having current source. Now third thing is write the KCL equation of that node. Similarly, repeat the steps 2 and 3 for other nodes. And at last, and the point number 5 is solve the equations and determine the voltages of the nodes. Then after getting the voltages, calculate the current in the desired branch. Once the current is calculated, we can calculate the voltage drop and power loss by the given formula. Voltage we will determine by current into resistance and power loss we will calculate by I square into R. So these are the steps by which we can calculate the voltage of a node, and after that we can determine the currents as well. Now I am trying to explain this method with the help of one example so that it will be clear to you. Let us have one example. Suppose I am taking example of an DC circuit. Suppose this is 10 volt, here 5 ohm, here 10 ohm, here 15, and here one current source is there. This is 10 ampere. So the first step is identify the nodes. So this is one node, this is second node, this is third node, and this is fourth node. But so this is node 1, this is node 2, this is node 3, and this is node. So these are the nodes. But as I mentioned in the steps, now this circuit is having 4 nodes. But if you see the voltage at this node, because we will make this node as a ground, so as soon as I will make this node as a ground, the potential of node 4 will be 0. So if I calculate the voltage of this node 1, that is V1, which is directly known to us, that is 10 volt. So there is no need to take this particular point as a node. If you are taking it, since this particular point is at ground, so straightforward the value of V4, since the fourth node is ground, so what is the potential of node 4? 0. Since it is 0 and this is node 1, so the potential of node 1, if it is V1, that is 10 volt. So you can see here that this particular network is having 4 nodes, and we can make this node number 4 as a ground. There is no need to take this particular point as a node, because once we make this fourth node as a ground, the potential of this point is directly known to us, that will be 10 volt. Okay, so we are supposed to consider only this node and this node. So I can again rewrite it. This we are not supposed to take as a node. So 1 we will not take as a node. Now if we are not taking 1 as a node, so now this will be node 1 and this will be node 2. Now assume the value of voltages at this node. Suppose this voltage is V1 and this voltage is V2. So this circuit, you can see this is one of the node, this is another node, this is third node, and this is fourth node. You can make this fourth node as a ground. Once I make this as a ground, the potential of this point is directly known to us, that is V1 is equal to. So that means as the potential of this node is known to us, so there is no need to take this as a node. So let me remove this one, because the potential of this point is known to us, that is 10 volt. So what, as the direct voltage of this point is directly known to us, so there is no need to take this point as a node. Now since here we are not taking this as a node, so obviously now it will be node 1. Similarly, the objective of a nodal analysis, what we do, that we first assume the voltage at a particular node where the voltage is not known to us, and then we determine the current in the branch. So whenever the current source is connected in series with any resistance, the value of current in that branch will be directly 10 ampere. So as we know the current in this branch, so there is no need to calculate the voltage at this point. So this will also not be a node. So that means the effective node in this circuit is only 1. So now what we do, we will write the KCL at node 1. Now as in the method it has been mentioned, after identification of the node where the voltage is not known to us, whatever the branches are connected at that node, we are supposed to take the direction of current away from that node except current source branch. So as this branch is not having any current source, so the current in this branch will be away from node. This particular branch is also not having any current source, so that will be also away from node. But this branch is having current source, so the direction of current will be as it is as the direction of current source. So unfortunately this current is incoming to the node, so we are supposed to take that current direction that is incoming to the node. Now suppose this is I1, this is I2 and this is I3. So you can see that what is KCL? Incoming currents are equal to outgoing current. So what is I3? I3 is 10. What is I1? I1, as the direction of current I1 is from 1 to this. So what, suppose if the voltage at this one point, unknown voltage at node 1 is V1. So what will be this current I1? I1 current is nothing but it is the potential difference divided by resistance. So V1 minus 10 divided by 5. So the current will be V1 minus 10 divided by 5. Why I have written minus 10? Because the current is going in a voltage fall way. Now similarly, what is I2? What is the potential between this potential difference is V1. So V1 by 10. Now as per KCL, incoming currents are equal to outgoing current. So incoming current is I3. So this is incoming current, and this is outgoing current, and this is also outgoing current. So as per KCL, I1 plus I2. So as per KCL, outgoing current are equal to incoming currents. So that means I1 plus I2 is equal to I3. Now what is I1? V1 minus 10 by 5. What is I2? V1 by 10. And what is I3? That is 10. Now solve this. V1 by 5 minus 10 by 5 plus V1 by 10 is equal to 10. So this will be 2. And 2 will go here. So V1 by 5 plus V1 by 10, that is equal to 12. Now if I solve it, what I am going to get? 2 V1 plus V1 by 10, that is equal to 12. So 3 V1 by 10 is equal to 12. So V1 is equal to, V1 is equal to 120 by 3. So V1 is equal to 40 volts. This is the value of V1. Now, if my objective is to determine the current in this 10 ohm resistance, suppose in this numerical the question is determine the current in 10 ohms, this is 10 ohms, this is 10 ohms resistance using nodal analysis. So, what is the current in 10 ohm resistance? We know current in 10 ohm resistance is V1 by 10. And what is V1? 40 by 10. That means 4 amperes is the answer. Suppose the question is determine the current in this 5 ohm resistance. So that will be V1 minus 10 by 5. So current in 5 ohm resistance, that is V1 minus 10 by 5. So 40 minus 10 by 5 means 30 by 5, means 6 ampere will be your answer. Now similarly, suppose the voltage drop across 10 ohm resistance is asked. So voltage drop in 10 ohm resistance, what will be that value? That is 4 into 10. That means 40 volts. Suppose the voltage drop in 5 ohm resistance. Voltage drop in 5 ohm resistance. So what is that value? We know current is 6 and 5. So that is 30 volts. Okay. Similarly, if the power loss has been asked, power loss in 10 ohm resistance. So what is the power loss? I square into 10. What is I? I have calculated 4 amperes. So 4 square into 10 means 160 watts will be the power loss. Suppose the question is power loss in 5 ohm resistance. In 5 ohm resistance. So what is that? I square into 5. What is I square? 6 square into 5. So 36 into 5. So 3180 watts. That's the answer. So this is how we can solve the numerical by nodal analysis. The steps I think are clear to you. We are supposed to identify such nodes in a given circuit where the voltages are unknown. Then we assume the value of that unknown voltage. Then we write the KCL for that particular node and we solve the equations to determine the voltages. And once we know the voltages, we calculate the current after calculating the potential difference across the branch divided by the resistance. So my dear friends, now I'm stop sharing my screen. My dear friends, whatever information I have shared in this video related to the nodal analysis, that will be clear to you. I have discussed about the step-by-step process of solving the numerical by the nodal analysis. And then I have given one example, and by applying the nodal analysis, I have solved that numerical and already told you that how to determine the voltages, how to determine the current in a particular branch of the circuit, how to calculate the power losses in that branch. So now I hope all things related to nodal analysis will be clear to you. If you like this video, kindly press the like button. And if you feel that whenever in future I make such kind of videos related to network analysis, a notification should reach to you, then don't forget to subscribe my channel.